An embedding model converts data such as text, images, audio, or video into numerical vectors so that similar items are close together in meaning. In retrieval augmented generation system, embedding model creates vector embeddings for data before it is stored and indexed in the vector database. With many available embedding models, it may seem that choosing the right one for your use case is a very trivial task. It is, however, a critical decision that directly impacts the retrieval quality, performance, and cost of the retrieval augmented generation system. Before we learn the different factors that you should consider, let us understand a few foundational concepts related to embedding models. In symmetric embedding models, two texts are treated in the same way. This means the model is trained so that similarity between two texts is interchangeable. Similarity between app crashes when I log in and application fails during login is same in both directions. If you swapped these texts, the similarity task will still make sense. These models are typically used for duplication detection, semantic similarity between sentences, such as in resume to resume comparison, clustering, such as grouping similar support tickets, etc. Symmetric models assume that two texts are comparable in length, comparable in information density, and have the same task role, such as two sentences to compare. Symmetric embedding models are well suited for sentence to sentence usage patterns, where the goal is to measure semantic similarity or equivalence between two texts. Typical business use cases involve deduplication tasks or semantic comparison tasks. Many commercial and open source embedding models fall in this category, including All Mini LM or Paraphrase MPNet Base, etc. In asymmetric embedding models, the two inputs play different roles, most commonly a query and a document. Here, the query is usually short and intent driven, while the document is longer and information rich. For example, for query, how do I reset my password? The response will be longer with detailed steps for changing passwords. This model is trained so that query embedding is optimized to retrieve relevant documents, and the document embeddings are optimized for being searched. You cannot swap the two for the task to still make sense. This is commonly used in retrieval augmented generation systems, question answering systems, or search engines. Asymmetric embedding models are trained to support query to document usage patterns where the two inputs play different roles. One input, the query, represents an information need, while the other, which is the document, represents a source of information to be retrieved or matched against. Typical business use cases involve retrieval augmented generation, enterprise search, or Q&A use cases. Many commercial and open source embedding models fall in this category, which includes OpenAI text embeddings, Cohere embedding models, Titan embedding models, etc. Symmetric embedding models are also used for clustering of data by grouping semantically similar items together. Typical use cases for clustering include topic mining over knowledge bases or customer segmentation from reviews, etc. Both symmetric and asymmetric embedding models can be used in retrieval augmented generation pipeline, but for different purposes and at different stages. A symmetric embedding model can be used during pre-processing tasks, such as deduplication of chunks. After cleaning the dataset, an asymmetric embedding model is used to build the final retrieval index. This model is optimized for query to document matching, which aligns with the retrieval pattern in retrieval augmented generation systems. To select the right embedding model for a use case, it is important to consider the training objective of the model and whether it is designed for symmetric or asymmetric similarity. Models that are trained with a query to document, which is asymmetric contrastive objective, are typically used for indexing documents or chunks in a retrieval augmented generation system. In contrast, symmetric embedding models are better suited for semantic similarity tasks such as clustering, topic mining, duplicate detection, where both inputs are treated equal. Besides matching the training objective, you can check the leaderboards such as massive text embedding benchmark from Hugging Face to compare overall performance across various tasks such as retrieval and clustering. You can also explore model details, community usage, and open source options. The most important test, however, is to evaluate the shortlisted models against your own data set to ensure that they perform well for your specific use case. Some other considerations include you need to decide between open source and proprietary models. Open source models offer flexibility and control, while the proprietary models offer strong out of the box performance. Open source models can be hosted on prem, which can be important for compliance reasons in certain organizations. They can also be cheaper than commercial proprietary model, and they allow customization using fine tuning by using organizations' domain data. However, this requires expensive development resource and expertise. Another key factor is dimensionality of the model. Higher dimension models create larger embeddings that can capture richer meaning. But large embedding means more storage and compute requirements and increased latency. Many use cases can do very well with smaller dimensionality models, so experiment to see which size fits your use case. Most production systems cluster around 512 to 1024 dimensions, with 1500 and above for heavier enterprise and multilingual workloads, and 2000 and above is for niche use cases. Vector embeddings support different similarity metrics such as cosine similarity, dot product, and Euclidean distance. While cosine and dot product are commonly used for embedding based retrieval, Euclidean distance measures absolute vector distance and is more sensitive to magnitude differences, like how big is the vector, is also important there. In vector database setup, you choose the similarity metric, such as cosine or dot product, to compare query embeddings with the document chunks. It is important to be consistent with how the embedding model was trained and was intended to be used. Cosine similarity and dot product produce equivalent results when the embeddings are normalized, which means they are transformed to have a unit length of 1 while keeping their direction the same. Therefore, consistency in embedding normalization is more important than strictly matching the metric. But the key point to remember here is that your model should have been trained on same or similar similarity metric as you choose in your vector database. Latency is equally important both during the embedding generation and also at the time of query retrieval because it directly affects the user's experience. So it's important to test your embedding model against your use case requirements. And you must consider scalability and cost of embedding model, especially when working with large volumes of data. So, in summary, selecting an embedding model requires careful evaluation and experimentation. It is not just a technical choice, it's a design decision that shapes the effectiveness of your entire retrieval system.